Let's take a look at an example here quick. For this one, if I asked you to find the area and perimeter for this, so area and perimeter, they would both be very, very similar. What I have is a rectangle in the middle with a half circle on each end. So for finding the area, first thing I have to do is I have to find how long the rectangle is. How would I go about doing that? I'll give you a hint. What's that length? What's the radius of that half circle? What's the diameter of the half circle? Yeah, the diameter is 40 all the way across here. So the radius has to be 20 feet. Which means that radius is 20 feet in every direction. So it's 20 feet in this direction too, right? So how far is that? 20 feet. How far is that? 20 feet. So it's 150 minus 20 minus 20. This is 110 feet here. So from here to here is 110 feet. So I'm going to start out with that rectangle. The area of that rectangle is 110 feet times 40 feet, or 4,400 square feet. Next, I'm going to look at the two half circles. Only I'm not going to look at them as half circles. I am going to take that and that, and I'm going to do this with them. What happens when I put them together like that? What do I get? I get a full circle. Good. What do I know about that first full circle? Well, it has a diameter of 40 and a radius of 20. So to find its area, it's pi times radius, pi times 20 squared, otherwise known as 1,256 square feet, right? So we add that up. It's 5,656 square feet is its area of that whole figure. Any questions on that? You look confused. Okay, no problem. Perimeter, we're just adding up the sides. Well, we already figured we got 110 here. We have 110 here. Do we need to add in the 40s? No, because those aren't on the outside, are they? So we just have 110 and 110. Then what we have to add up is these half circles. Well, again, those half circles are just the distance around this full circle. That circumference is pi times 20 or 40? Pi times diameter for circumference. Pi times 40 for that one, which will be 125.6, right? Yeah, we don't need to divide it down because it's, we put it together. It's the full circle is there, right? So we're gonna, but that's a good thing. That is what it would be for each half circle. But since we have two half circles, it's one full circle, and let's make it easy on ourselves, right? So the head is going to be 345.6 feet of perimeter. The reason I showed you that problem was so I can show you this one. So for this one, we have a diameter here. Let's call this one 60 feet. I'll give you this distance here of 100 feet. And I'm going to say that this, from here to here, we're going to call that 15 feet. Let's make it easier on ourselves. We'll call it 10 feet. I want to know the area of the track. I want to give you guys a second to think about it, then we'll talk about it. So for areas, here I have two rectangles. I have this one and this one. Now, fortunately, they're both the same size. Those rectangles are each 100 by 10, or 1,000 square feet each. So I'm just going to write that down twice. So that's my two rectangles, here and here. But now I got the same type of deal here with these ends. That wasn't what I wanted to do. So, when we put them together like that, what do we get? Circle type deal. And we've done this before. We've worked on something like this, similar to this before, where we have a ring. We have the big circle and the little circle inside. This was 60 feet diameter, so that means the radius of the big circle is 30. Since it was 10 feet across here, that means the radius of the little circle is 20. 30 minus 10, right? So what we have for that area around this ring, we've got pi times 30 squared minus pi times 20 squared. So pi times 30 squared is 2826. Pi times 20 squared is 1256. We subtract. You get 1570 is the area of that. So it's 3,570 square feet. Not so bad? Yeah, not too horrible. And perimeter would be found the same way as we did before. You've got 100 here, 100 here. You'd find the distance around the outside of the circle. That'd be pi times pi times 60, right? Diameter for circumference, right? That would be the outside. On the inside, well, still 100 here, 100 here, plus the distance around the small circle. That's 20 radius, or diameter 40, so pi times 40 would be that. Now that would give you your two perimeters, the outside perimeter and the inside perimeter. Make sense? So with that, I'm going to leave you with this packet, this new packet. There's problems. I know there's problems at the very end, but there might be some scattered through. I think they're all at the end, the last couple pages of that packet. We'll talk about them more on Monday. Probably going to be another quiz on Monday, just on the areas and perimeters and stuff.